All right, right back at it with Module 3, Lesson 3. And our objective is we will be able to add fractions with unlike units using the strategy of creating equivalent fractions. All right, so our directions say that we're going to use the rectangular fractional model to find a sum. So we're going to simplify our answers if we can. 1/4 plus 1/3. Remember, we're not just adding straight across saying 2/7. What we have to do is show 1/4 on our first model, and then we're going to show 1/3 on our second model. So when we show our 1/4, we're going to set it up so that we set our partitions up vertically, go straight up and down. So we have our vertical partitions. Now what we're going to do is shade in our 1/4. So now we have 1 out of 4 shaded in here. You can see my whole equals the 4/4, and I have shaded in 1/4. Now for my second adding, my 1/3, I'm going to set my partitions up horizontally. Remember, if I have 3 parts, I need 2 partitions. So you see my 2 partitions set up horizontally, and I'm going to shade in my bottom third. So you see I have 1/3 shaded in at the bottom, a third in the middle that's not shaded in, then a third at the top that's not shaded in. Right here we have 1/3 represented, and here we have 1/4 represented. Now to get equivalent forms, if I take my horizontal partitions here and set them up on my first model, take these horizontal partitions and set them up, that 1/4 becomes 3/12. Same thing here. I'm going to take my 3 vertical partitions from my first model and put them on my second model here. And now you can see that we started off with 1/4, and that's equal to 1, 2, 3 shaded in out of 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/4 is equal to 3/12. And then I also had 1/3. That's what I started off with, that bottom third. And I know that's equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be equal to 4/12. All right. So now when I add those two together, I have 3/12 plus 4/12. And you notice I have 1, 2, 3, 4, 5, 6, 7, 12 shaded in. So I have my 3 on my first model and my 4 on my second model to equal a total of 7/12. So this is equal to 7/12. All right, let's take a look at B. Same thing, I need to represent my 1/4 and my 1/5. I'll go ahead and set that up. My 1/4 is set up with 3 vertical partitions. And I'm going to shade in 1 out of the 4, similar to my first problem. So I have 1/4 shaded in. For the second adding, now I need fifths. So I have fifths here, 5/5 equals a whole. I'm going to shade in 1 out of the 5/5. All right, so now we have to make our equivalent fractions. So I'm going to take my horizontal partitions, 1, 2, 3, 4 horizontal partitions, and just simply move them to my first model. So we're going to say that's 1, 2, 3, 4. And then I'm going to do the same thing on this side with my vertical lines. I'm going to take my 1, 2, 3 vertical partitions and move them to this side, vertically in the middle, and each vertical half in half. All right, so now we say, well, I'm just taking this information that's horizontal here, and I'm going to set it up vertically. So we had 1/4 plus 1/5. And before we can add, we can't add unlike denominators, so we have to find equivalent fractions to 1/4 and 1/5. So now I can say, well, I see 1, 2, 3, 4, 5 out of 10, 15, 20. So that's 5/20ths. And this is 1, 2, 3, 4. Each row is going to be 4, so the next row will be, when we add it to the first row, will be 8. We have 12, 16, 20. So that's 4/20ths. When we add 5 and 4 together, we get 9/20. This is equal to 9/20. And if you notice, our denominators, when we multiply them together, our original denominators, the unlike denominators in our first two addends, when we multiply them together, we get our new denominator. I'm going to show you how that works on the next slide. All right, so let's look at C. We're doing the same thing that we did with A and B, except for now we're going to show you how we're going to multiply those denominators in order to come up with our new denominator. So make sure we're paying attention here. So first we have 1/4, and then for our second addend we have 1/6. So quickly show the 1/4. Vertical partitions, 3 partitions give me 4 parts. One of those 4 parts can be shaded in. All right, so that's my 1/4. Then I'm going to have for my second addend 1/6, 1 out of 6. 5 horizontal partitions, 1, 2, 3, 4, 5 gives me 6 parts. 1 is going to be shaded in. All right, now I'm just going to duplicate my partitions. My horizontal partitions for my second addend is going to go in my first picture, and my vertical partitions from my first addend is going to go in my second picture. So let's go ahead and do that now. All right, so we had 3 partitions here. I'm just going to duplicate those 3 partitions, 1 in the middle, in each vertical half in half. And for my first rectangular model, I'm going to go ahead and make my 1, 2, 3, 4, 5 partitions. And now let's go ahead and total everything up here. So we said 1/4 plus 1/6. I would always suggest adding these up vertically when you have unlike denominators, because this is ultimately what we're doing. We're multiplying by 1 whole to get our new denominator. So we're going to say, well, we're going to take this 6 from this bottom addend and put it as a whole here. 1 whole in the form of 6/6. Then we're going to take the 4 from our top addend, or our first addend, and put it as 1 as a fraction form of 4/4 here. So remember the rule of multiplication. Anything times 1 equals itself. So anything times 1 equals itself. So when I multiply 1/4 times 1, even though it's fraction form of 6/6, I still get 1/4. It's just in a different or equivalent fraction. So now we say, well, 6 times 1 is 6. 4 times 6 is 24. And of course, 1 times 4 is 4. And 6 times 4 is 24. So you should see 1, 2, 3, 4, 5, 6. Second column will be 12. Third column will be 18. And the fourth column will be 24. So that's 6 out of 24 shaded in for my first addend. My second addend, I have 1, 2, 3, 4. And the next row will be 4. Another 4 will be 8, 12, 16, 20, 24. So I know when I have 6 24ths plus 4 24ths, that's going to give me 10 24ths. 10 24ths. I can simplify this because I know that both of these numbers are divisible by 2. So I can say, well, this is going to be equal to 5/12. All right, let's go ahead and take a look at D. So now we have 1/5 plus 1/9. Show that 1/5. Vertical partitions, 4 lines, gives me 5 parts. 1 part shaded in. Then we have our 9ths. Okay, so now what I'm going to do is addends at the bottom here, and I'm going to show my equivalent fractions. I should be able to see that. I'm going to say, well, times what equals what, times what equals what. This fraction here that I'm multiplying has to be equal to 1. And what I want to do is take the denominator and multiply it by the opposite addend. So this 5 is going to come down here as a fraction of 1, 5/5. This 9 here is going to go up here as a fraction of 1, 9/9. Then I say, well, 9 times 1, 9. 5 times 9, 45. 1 times 5, or 5 times 1 is 5. 9 times 5, 45. So you can see here we have 14/45 in all. Let's see if our area model or our rectangular fraction model adds up to the same thing. So we're going to have to duplicate 1, 2, 3, 4 vertical partitions on this second picture here. Let's go ahead and make those vertical partitions. 4 is even number, so I'm going a little bit less than half. 1, 2, 3, 4. All right. Then I'm going to make my 1, 2, 3, 4, 5, 6, 7, 8 partitions. Remember, if I want ninths, if I want 9 parts, one less is going to give me the number of partitions. So 8 partitions give me 9 parts. So I'm going to do my horizontal partitions here. I need 8. 1. It's a little off here. I'm just going to go ahead and put that there. All right, so you can still see my 1, 2, 3, 4, 5, 6, 7, 8, 9 horizontal rows. So now let's go ahead and count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of, that would be 9, 18, 27, 36, 45. So that would be 9 out of 45. And I was just counting each column is 9. So my multiples are 9. 9 times 5. And here it's going to be 1, 2, 3, 4, 5. So I'm going to skip count by 5s going each row. So that's 5, 10, 15, 20, 25, 30, 35, 40, 45. So 5 out of 45. You see my 9/45 and my 5/45. Add them together, 9 plus 5, 9, 10, 11, 12, 13, 14. So I get 14/45. All right. Last but not least, let's look at E and F. For the last one, for D, we didn't have to simplify because it was, we know that 14 and 45 do not have any compatible numbers. And when I say that, I say, well, thinking about the divisibility, multiples of 14 are 1 and 14 and 2 and 7. And when we look at 45, we get 1 times 45, 3 times 15, and 5 times 9. These are all your factors of 45. What times what equals 45? None of these numbers other than 1 show up on both lists. All right, so let's go ahead and take a look at E here. E, we have 1/4, so we're going to shade in that 1/4. All right, and then we're adding, our second add-in is 2/5. So now we're going to shade in 2 out of the 5/5 in this whole. All right, so let's go ahead and set this up vertically so we can take a look at what we need to do. So I like to write in that times what equals what, times what equals what. Now you don't have to do this for this lesson, but I'm just kind of giving you a glimpse of what's to come. All right, so now we're going to set up our horizontal lines. 1, 2, 3, 4 horizontal partitions on this first model, and 1, 2, 3 vertical partitions on the second model. Let's go ahead and knock out the vertical lines first. So 1, 2, 3. And for our horizontal lines, we have 4. So we're going to go 1, 2, 3, 4. All right, so now you can see on our first add-in, or 1/4, which was 1/4, is now equal to 1, 2, 3, 4, 5 out of 5, 10, 15, 20. It's 5/20ths. And you can see here, this, which was originally 2/5, is now 1, 2, 3, 4, 5, 6, 7, 8 out of 12, 16, 20. So it's now 8/20ths. All right, and if you remember what I said earlier, a way that we could have got here faster without this model, which we're going to be working on next, is to take this 4, bring it down as a fraction of 1, so 4/4. Then we're going to take our 5 here and bring it up as a fraction of 1, 5/5. That's all we're doing. 1 times 5 is 5, 4 times 5 is 20, 2 times 4 is 8, 5 times 4 is 20. All right, so we know that 5/20ths plus 8/20ths is 13/20ths. We should have 13/20ths, 8, 9, 10, 11, 12, 13. This is equal to 13/20ths. Once again, I'm not able to simplify that because 13 and 20 don't have any factors other than 1 compatible factors. All right. So the greatest common factor will be 1 for those two numbers. All right, let's take a look at F, our final problem here. We'll say F, I'm going to clear this out. We have 3/5. So I need to shade in 3 out of the 5. Make our highlighter a little bit bigger here. So that's 3 out of my 5. And then for the next one, we're going to shade in 3/7. Let's go ahead and do that. All right, let's go ahead and now we're going to just go ahead and write in our vertical add-ins. 3/5 plus 3/7. Remember, unlike denominators, red flag should go off. I can't add those. So I need to find a common denominator. And what I'm going to do is, once again, draw my lines across. So my horizontal partitions are going to come over. So I need 6 horizontal partitions to give me 7 horizontal sections. And then on this one, I need 1, 2, 3, 4 vertical partitions to give me 5 parts. 1, 2, 3, 4. Not perfect, but we'll take it. All right, let's go ahead and count. I know that in each one of these rows, there's 1, 2, 3, 4, 5, 6, 7. So if there's 7 in each one of these 3 rows, how many do I have in all? 7 times 3. That's 21. So I know that I have 21 here. And if there's 7 in each row and I have 5, that would be 21, 28, 35. All right, so let's go ahead and look at our horizontal. So we have 5 going across horizontally. So that means I have 3 rows of 5 is going to be 15. And then I have 7 rows of 5 is also going to be 35. So if you notice, 5 times 3, if I took this 5 and made it as a fraction of 5/5, which is equal to 1, let's say 3 times 5 is 15, 7 times 5, 35. Then I will take my 7 and make it as a fraction of 7/7, which is equal to 1. 3 times 7, 21. 5 times 7, 35. Right? So now we say, well, 35 is our units. We have 21 35ths plus 15 35ths. 1 plus 5, my 1 in my ones place, plus my 5 in my ones place. It's going to be 6 in my ones place. Then I have 2 10s plus 1 10 is 3 10s. So I have 36 35ths. I know that 35 35ths is equal to 1. So I'm going to take those 35 35ths and make it one whole, and I have 1 35th remaining. Something that we didn't get to see that I thought we were going to go back to. Let's take a look at C here. I know I jumped away from this, but I want to show you how I got that 5/12. Let's go ahead and list our multiples here, and that'll give us a chance to see how we are simplifying. All right, so when we look at this, we say that something looks like this number can, both of these, our numerator and denominator, can be reduced. So what we do is we list our multiples of 10. What times what equals 10? I like to start with 1 because you know that it's always going to be 1 times the number. So I say 1 times 10, and I also know that it's 2 times 5. If you notice, I list them in order from least to greatest, 1 being the lowest number, 10 being the greatest, and I also put my little pairing marks on top. My 1 and my 10 go together. 1 times 10 equals 10. And then my 2 and my 5 go together. 2 times 5 equals 10. And I'm going to do the same thing for 24. Well, I know it's going to be 1 and 24. It's an even number, so 2 and 12. 3 also. 3 and 8. Last but not least, 4 and 6. So now I have to say, well, what numbers, and I'll pair these up as well. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So now I say, well, what numbers shows up on both lists? I see 1 on both lists, 2 on both lists. I want to divide by my greatest common factor. My greatest common factor is 2. So 10 divided by 2 is linked to 5. So I know that's going to be 5. And here, 24 divided by 2, well, 2 is linked to 12. It's going to be 5/12. That's how I got that. 10 and 24ths is equal to 5/12. All right. So any questions or comments, please post either in the comments below or ask them in class so we can address this. We will be doing a little bit more problems similar to this tomorrow. Happy learning. Keep up the good work. Don't forget Zern, Zern, Zern. If you didn't do your Zern lesson 3, please go ahead and do that before we get to class because we will be taking our exit ticket tomorrow.